Welcome to our lesson on graphing radicals. So we're just going to continue on from the previous lesson. I just broke up the two different topics into two lessons, but they are kind of similar to each other. In this case, we are going to graph our radical when we're given the equation. Now this is the general format of a radical, y minus k, where k is a vertical shift. A is the vertical stretch, B is a horizontal stretch, and H is the horizontal shift, so moving it from left to right. Also, take a note that you could write it like this as well. This is more common for you to see, that the k has been moved over to the other side because this plus k means we're going up. If you have a minus k, that means we're going down. You can also determine your starting point of your quadratic. It's kind of like your vertex in your quadratic, but in this case, because we're dealing with a radical, this would be a starting point. So this can be determined by hk. Again, very similar to how you'd find a vertex on your quadratic, and that would be your starting point for your radical. So for A, we are going to graph this following graph, state any intercepts, and find the domain in range. Well, we can pick up our starting point right away. We're going to have a point at -4, 0, because I would take whatever's on the inside. That would be my x value, but our general form is the minus, so that's why the -4 would cancel out with that minus to get a +4, and there was nothing on the outside of the radical, so we just have 0 as our y point. So that is our first point. Now we need to find a second point, and on any test or exam you need to find at least 2 points. So we have one already, and then we need to find one more. So since we have to find intercepts anyway, I suggest finding the y-intercept. That is when you set x equal to 0 and then solve for your y value. So this is 2 times the square root of 4 is 2. So we have a point at 0, 4. Now we're going to go ahead and graph this. So we have a point at -4, 0. That is our starting point. Then we have a point at 0, 4. Remember that the shape of a radical always looks like this, kind of like a parabola on its side but cut in half. And -4, 0 was our starting point. So I'm going to start from here, then connect to the other point in a similar shape, go a little further, and put an arrowhead. So that is our graph. Your x-intercept is -4. Your y-intercept is +4. Your domain from left to right, your most left point is -4, and we touch it and it goes on to infinity. Your range is your lowest y point, which is 0, and we touch it and that goes on to infinity. We're going to do another example here. So taking a look at our starting point, we don't have any shift. So our first coordinate is going to be 0. The -1 indicates we're going 1 down, and that would be your y value for the starting point. We need to find one more point. In this case, we just need to pick an x value that would satisfy taking the square root of that whole thing of 3x. So if I multiply this by 3, then I get the square root of 9, and I know what that is. So we're going to go ahead and do x equals 3, which is 3 times 3 minus 1. That's 9 inside the square root sign, and then minus 1. The square root of 9 is 3. So now we have 3 over 2 minus 1. which is 1.5 minus 1, we're left with 0.5. So that is our other point. Okay, so our starting point is at 0, negative 1. I'm going to start from here. Our second point is at 3, a half. And then we're going to connect those points by starting at our starting point to the next point, maintaining the same shape. Extend a bit and add the arrowhead. Your x-intercept we have to find. We're going to do this by setting y equal to 0. So I'm going to move the 1 to the other side. Then multiply both sides by 2. Going to square both sides to get rid of the square root sign. And then divide both sides by 3. So x is 4 over 3. Your y-intercept is at negative 1. Then we want to find our domain from left to right. Our most left point is at 0, and it goes on to infinity. For a range, our lowest y point is negative 1, and it goes on to infinity. Go ahead and try the next one on your own, and then when you're ready, we can go through the solution. So as a hint, your starting point will be 1, negative 4. Then you want to find another point, connect the 2 points together, extend a bit, and then you should be done. Here is the solution to that try it yourself. So your starting point is at 1, negative 4. Then you want to find the second point. So I just said that we could find another point with x equals 3. And I picked that for a reason. Since there's a half on the inside of our square root sign, I want to make sure that whatever number I pick for x minus 1 will give me a number that I can multiply by half that I can still take the square root of. So if you look at why I picked 3, if I do 3 minus 1, I'm going to get 2. 2 divided by 2 is 1, and then I just can take the square root of 1. If you have to take the square root of, like, let's say 5 over 2, that's rather difficult to do. So you want to make sure whatever number that you insert in for x, you can take the square root of the entire thing afterwards. So I picked x equals 3, and once I did and simplified, I got a y value of negative 5. So that means we have a point at 3, negative 5, and a point at 1, negative 4. When you graph this, you're going to plot those 2 points down, but when you're connecting, you're going to start from the starting point, which is at 1, negative 4, and then continue on. Take a note of the shape I have now, that it looks something like this, as opposed to something like this. The reason being is because we have the negative in front of the root sign, and this is a reflection down. Kind of again like your quadratics, if you had a positive in front of your x squared, it's going to look like it's smiling, versus if you had a negative in front of the x squared, your prop looks like it's upside down. Similar concept for your radical. Then your domain is going to be from 1 to infinity. Your range is from negative infinity to negative 4, because this arrowhead is pointing down towards negative infinity, and your highest y value is negative 4. And this graph doesn't have any intercepts. It will never touch the x-axis, nor does it ever touch the y-axis.